Hi everyone, welcome to part 3 of Recitation 0G, Debugging of Deep Neural Networks. As a fast recap, we have learned some good coding practices in machine learning projects and how to visualize data using matplotlib in part 1, and we have learned how to tackle syntax errors, logic errors, and how to handle runtime errors using PDB. In this section, we'll go through some more subtle problems including issues with time and memory. So now assume you have resolved all the obvious bugs in your code and your model is ready to be trained. So you happily start to run your code, but it's taking you 40 minutes to train an epoch while only taking other people less than 10 minutes to train a model of similar size. There are a few things you should check if the training time is too long. Firstly, check if you're using GPU. GPU is designed to do things in parallel, and hence they are very good at processing matrix and doing matrix calculation. So there's this concept of batch size in machine learning. Data is passed to the model in batches instead of one by one. And the larger the batch size, the more parallelized your training will be. However, GPU has its limits as well. And if the batch size is too large, it won't be able to process the whole batch together and have to break things down before processing them, which will make things slower. Hence, you should experiment with your batch size just like a hyperparameter, and find the batch size which results in the fastest computing. Third, you should check your data loader implementation and training loop. So most iterations happen there, and if you are doing something inefficient inside a loop that will be run a million times during training, that will accumulate and cost you a lot of time in the long run. Fourthly, we can use mixed precision during training. In machine learning, most variables store float numbers, and some float numbers require high precision. Others only require a low precision. So if we treat everything as high precision data, the computation will take longer. Luckily, there are existing functions we could call to automatically decide for us how precise the data must be. So you should search up mixed precision when you are writing your code. Lastly, you can use time module to check how much time each section of your code is taking and optimize the code based on that. Lastly, we have memory issue. So one thing that commonly happens during training is that after some time, your computer runs out of memory and you lose all your progress. Of course, the very first thing you should do to avoid this problem is to make sure that your code automatically save your best performing model every epoch, and you will be able to continue training the model from there. However, CUDA out of memory is still annoying to deal with. So when you see this error message, try reducing your batch size and again use mixed precision, as it not only saves time, but also memory. Some other common errors that could lead to CUDA out of memory is that you did not use torch.inference model during validation and testing. So in inference mode, your model only needs to make predictions and it does not need to think about how to improve itself, which takes a lot of time and memory. So when we are not training the model, but only using the model, we should use inference mode to prevent memory waste. Also, you can try torch CUDA empty cache. It helps reducing fragmentation of GPU memory. Another common memory issue is forgetting to move data to GPU. So we'll see this error message if that happens. What causes this issue? Basically, in order to train a model on the GPU, it is first necessary to send the model itself to the GPU as follows. And then during training or testing, we need to send the data to GPU so that the model can access them. If you are not careful, there might be a mismatch between the location of data used in a function. To debug this kind of issue, you can print the location of data by printing out device using this line of code. And also, to move the data from CPU to GPU or from GPU to CPU, you can use these two lines of code. That's all for Recitation 0G. Thank you.